In my previous video, I showed that the flat Earth model is flat out wrong. And what I showed was that in New Zealand, when it's sunrise in New Zealand, December the 22nd, the sun rises from the southeast. But on the flat Earth model, you should be seeing the sun rise from the northeast. And we know the sun's right overhead in South America. However, we have to look southeast to see the sun. And as I explained in my video, this can only be explained with a globe model of the Earth. It cannot be explained by any flat model of the Earth. If you haven't seen the video, please go see the video where I explain in detail how it can be that the sun rises southeast from the observer in New Zealand. In this video, I want to focus on the equinox, as the equinox is coming up, March the 20th. As you may know, equinox is the day where the sun rises exactly east in every location in the world, and it is also the day where it's exactly half night, half day for every place in the world, in exactly 12 hours day, 12 hours night. And we're going to talk about how the sun's path in the sky works out on the equinox. So this area over here is night, this area over here is day. We're going to look at the equinox in Singapore, how the path of the sun will flow in Singapore. So the first thing we have to know is that at sunrise, the sun will be 45 degrees. In other words, this will be north. The sun will rise exactly northeast, 45 degrees, and make a semicircle over the sky, come right over your head at the equator, and then make another semicircle and set 12 hours later. Now we can work out how high in the sky the sun should be from the observer in Singapore. Now if the sun is 3,000 miles high, and we can work out the equator to the North Pole is 5,400 miles, so therefore this line over here will be 7,636 miles. So with a bit of trigonometry, we can work out that the sun will be 23 degrees above the horizon. So the sun azimuth will be 45 degrees. So the azimuth refers to north, south, east, and west. So 0 degrees is north, 45 degrees is northeast, and 90 degrees will be east. And the altitude in the sky will be 23 degrees. That's how high in the sky the sun should be when the sun rises. This is what the path in the sky the sun should take in Singapore. It should rise 45 degrees northeast, 23 degrees high in the sky, not at the horizon, but 23 degrees high in the sky. Come right over your head and set 45 degrees northwest, halfway between north and west. But what do we actually observe in reality? In reality, the sun rises due east and sets due west and comes right over your head. All right, so let's see this in 3D. We have here a sun simulator, and as I just said before, the sun at the equator, which is 0 degrees north, so this is the equator, the sun should be rising exactly east, going over your head, exactly over your head, and then setting exactly west. That's what happens on the equator on the equinox. Now, let's see what happens in other latitudes on the equinox. On other latitudes on the equinox, the sun rises exactly east, sets exactly west, but the path the sun takes in the sky will not go straight over your head. The only place in the world where the sun will be over your head on the equinox will be on the equator. The only day on the year that the sun rises exactly due east and exactly due west is on the equinox, 2 days a year. If it's not the equinox, this is what happens. This is the path of the sun. In June, the sun rises northeast, rises straight up, and goes overhead and sets northwest slightly. But this is at the equator. At other latitudes, everything's quite different. So this is the summer in the northern hemisphere. This is the equinox, and that's the winter. So the only day of the year that the sun actually rises exactly east is on the equinox. All right, so as you change the latitudes, you can see the path of the sun changing. And you can work out where you are just by looking how high the sun will be in the sky. So as you can see, if I move 10 degrees north, I would expect my sun to deviate from right up top of my head 10 degrees. If you move from the equator 20 degrees north, the sun will move 20 degrees south. If you move from the equator 50 degrees north, the sun will move 50 degrees south. In other words, the sun's altitude will be 40 degrees high because 90 minus 50 equals 40. So just by looking at how high the sun is on the equinox, you can work out what your latitude is. But what is the arc, what is the shape of the path of the sun according to the flat earth model? According to the flat earth model, the sun will rise 45 degrees azimuth and 23 degrees above the horizon. So the sun will rise at this point, make an arc in the sky, reach above your head, and then set halfway between north and west at that point. So as you can see, the path the sun actually takes in the sky on the equator, on the equinox, is very different than the path what is predicted by the flat earth model. And because it's so different, we have to say that the flat earth model is wrong. Because if the flat earth model was correct, it should be able to predict exactly the movement of the sun in the sky at all times, at all locations, but it doesn't. It gets the path in the sky completely wrong in every single location at all times. So therefore, we have to conclude that the flat earth model can't be correct. It doesn't really matter what the exact map will be of the flat earth community, whether they change it slightly or they make it into a square shape or rectangle shape, triangle shape, it makes no difference. The only shape that explains the path of the sun in the sky every single day, every single time, from every single location is the globe. The flat earth model gets the path of the sky the sun takes wrong almost every single time. In almost every single situation, the path in the sky the flat earth model predicts should happen, does not happen. And therefore, it is wrong, and therefore we must reject it. If you enjoyed this video, please give a thumbs up and share with all your friends, and especially with flat earthers. I will be making a part 2 on the equinox, so please stay tuned. Until then, have a great day.